All right, let's talk about two of the most important building blocks in all of programming, stacks and queues. Now, they might sound a little technical, but I promise you, the logic behind them is super simple, incredibly powerful, and you are using them constantly, probably without even realizing it.
So, to get started, let's look at a feature we all use every single day, probably without a second thought. That little bit of magic we call undo. It feels like magic, right? You make a mistake, you hit a button, and poof, it's gone. But it's not magic. It's actually a really elegant solution for tracking your actions, and the secret is a data structure designed for exactly this kind of reversal. And that structure is called a stack. The core principle here is last in, first out, or LIFO. Honestly, the best way to think about it is like a stack of pancakes. You always take the one off the top, right? The last one you put on is the first one you eat. This last in, first out behavior is absolutely perfect for anything that needs to happen in reverse. Like undoing your last few edits or clicking the back button to retrace your steps through websites. So when we add an item to a stack, the operation is called a push. Let's see it in action. We start with an empty stock. We push the number 87 onto it. Then we push 63, which goes right on top. And finally, we push 94, making it the new top of the stock. And to take something off, we pop it. Now, here's the key. You don't get to choose which one to take. You have to take the one on top. So we pop 94 because it was the last one we put in. Pop again, and we get 63. See? Last one in is always the first one out. That's LIFO in a nutshell. Okay, so stacks are great for reversing things, but not everything in life should work in reverse. What about situations that need to be fair? Where the first person to show up should be the first person to get help. Well, that requires a completely different approach. I mean, just imagine waiting in line at a grocery store. You'd be pretty upset if the person who just showed up got to go first, right? The whole logic here is flipped on its head. And this is exactly where the queue comes in. It follows a first in, first out rule, or FIFO. It works just like a real-life line. The first one to get in is the first one to get out. Simple as that. Okay, so adding someone to the back of the line is called NQ. So first, Mel gets in line. Then we NQ Nina behind her, and then Ruth joins at the very end. Now, when it's time to serve someone, we DQ them from the front of the line. So, of course, Mel is the first to go. So let's just put these side by side for a second. The really crucial difference is where you access the data. With a stack, everything happens at the top. You push on top, you pop from the top. But with a queue, you've got a two-way street. You add to the back, and you remove from the front.
Okay, so we know what they do, but how does a computer actually, build one of these things? Let's take a quick peek under the hood. What you're looking at here are the two most common blueprints. That first diagram, the one with the connected boxes, is a linked list. You can think of it like a chain. The other one, that block of cells, is an array. That's more like a fixed row of mailboxes. So what's the real difference? Well, linked lists are super flexible. It's really easy to add or remove links anywhere in the chain. Arrays are a bit more rigid, but they can be a lot faster if you need to jump straight to a specific item. Programmers pick one or the other based on what they need for a particular job, but either one can be used to build a stack or a queue. So a stack lets you work from one end, and a queue lets you work from opposite ends. But what if you need total flexibility? What if you want the best of both worlds? Yeah, imagine a line where people could not only join at the back, but also at the front, and they could leave from either end, too. For that, you need a kind of hybrid structure. And that brings us to the DEQ, which is short for double-ended queue. Now, you'll see it's called an ADT, or abstract data type. Don't let that term scare you. It just means it's a concept, a blueprint for how to organize data. And this particular blueprint gives you the powers of both a stack and a queue all rolled into one. And here's a little pro tip for you so you can win your next trivia night. Even though it's spelled DEQUE, everyone pronounces it deck, just like a deck of playing cards. And you can see right here why it's so powerful. You've got all the options. You can add to the front, or you can add to the back. You can remove from the front, or you can remove from the back. This total flexibility makes it an amazing tool for solving more complex problems. Okay, so let's bring this all home. Why does any of this stuff matter outside of a computer science classroom? Well, it's because these aren't just abstract theories. They're the silent, invisible organizers that are working behind the scenes in pretty much all the software you use.
every single day. Think about it. Your browser's back button, that's a stack. Your printer handling jobs in the exact order you sent them, that's a queue. Your computer's operating system deciding which program gets to run next, yep, that's often a queue too. They are absolutely fundamental.
Ultimately, these incredibly simple rules, last in, first out, and first in, first out, are what bring a sense of order and predictability to our incredibly complex digital world. Once you see them, you really do start to see them everywhere. Which makes you wonder, what other invisible rules are running your digital life right now? Thanks for watching.